All right, so in honour of a couple of things, I changed my first slide in honour of Kate's plenary today for an original artwork done a little while ago by my daughter. I also changed the background of my room. Chris Hassel yesterday made a rude comment about how messy my office was, so I've moved my picture of Godwits flying over the Manukau Harbour. So as Rich said, this is a talk that's not necessarily exactly about climate change per se, but it is about global change, shall I say. And it's work that sort of pulls together work that Jesse Conklin and I have done over the past 12 years, and others I should say, about the timing of migration of Godwits. So this is a talk that is based upon tracking, but the tracking isn't the focus of here. This is the tracking we did this year on the northward migration. So this is just to illustrate that what I'm interested in exploring here is the stopover period in Asia of Godwits on their way from New Zealand to Alaska. So the work I will be referring to comes from two places, from the Firth of Thames in Auckland, where we did satellite tracking, and the Manawatu Estuary, which is our little local study site. So we used geolocators down here in 2008 and 2009, and then again about 5 years later, 2013 to 14. And these time periods are quite important for the talk. The other place was up at Auckland, Pukorokoro, Miranda, where we put satellite tags on this year as part of a large tracking endeavour. The other thing we have at the Manawatu Estuary is sort of unparalleled conditions for doing resightings of birds. And so this is what Jesse spends every March doing, is keeping track of individual Godwits. So here are 9 discernible codes in one photograph, and we have up to about 40% of the small population of 150 to 180 birds that are colour marked every year. So this monitoring has been going on since 2008 continuously, and we'll see what we manage to do next year. Now we've profited off this, shall I say, a little bit, to do with consistent annual cycles of Godwits. I published a paper in 2006. Jesse, Murray Potter and I published one in I think 2013 or something like that, all about how consistent Godwits are in their migration timing. And part of the reason was that they were. And here's an example. One bird noticed departure dates 5 years in a row, the 12th or the 13th of March. So this is the pattern that we had. We know that some are more variable than this. In fact, this was the least variable of all of them, but pretty impressive. The other thing that Jesse's work really showed was the importance of understanding Alaska geography when we come to try to understand the timing of migration. And we published this work, which really found out for us that the key to understanding this is the difference between southern Alaska, middle Alaska, and northern Alaska, because the thaw in the southern part of the range is considerably earlier than the thaw in the northern part, and that difference in timing feeds right back to when they leave New Zealand. So in fact, it's really quite nice because it's more than just timing, it's also size and plumage. So we have large pale birds in the south of the range, small dark birds in the north of the range, and the timing in New Zealand reflects this. So if you want to see good looking Godwits, come in late March when all the pale ones have left. Through this talk, I will refer to these 3 areas of Alaska, just as south, mid, and north. So the 2 questions that I'm going to address how does stopover length in Asia relate to migration timing, and you'll see in more detail what I'm doing there. And then the other thing is migration timing changing? It's a changing world, climates are changing, even though this is a highly consistent species. Should we be expecting there to be differences? And like all good stories, when we started, we thought we knew what we were talking about, and things were quite simple. So what we have here is a really nice and intriguing plot of when birds arrived in Asia versus how long they stay, and the colors denote which part of the breeding range they are from. And it's this really weird pattern that wouldn't be explicable if you didn't know where they were going to. And that's that the early arriving birds stay for a long time, and then their length of stay gets shorter and shorter, which is in a way what we might expect if they're trying to leave at the same time. But then the northern birds all arrive at the same time. And then you look at what happens when they leave, because these ones stay for longer, they stretch out their timing. So in essence, you get this sort of symmetrical pattern of length of stay with arrival date, versus length of stay with departure date. So what happens is that the southern birds arrive over a long time and leave all over a short time. The middle and northern birds arrive over a short time and stretch their migration out to leave over a longer time. And this is what generates the pattern with when they arrive in Alaska. So this is a really cool pattern. It's quite sort of intuitive when you look back if you know where they're going to. If you don't know where you're going to, it's quite difficult to explain. And the other thing is, because we know that these birds are consistent year after year, we believe this is a fundamental pattern rather than just birds trying to catch up because they are late. So that was all cool, 2008, 2009. We did more tracking. I thought, right, let's bulk the samples up and let's see, let's get an even better data set and then publish this finally. And, oh, sorry, the other thing I meant to just show was, these are just demonstrating the difference in the arrival times, etc., of the span of the southern birds versus the northern birds and where they are. And we'll do that again with later plots. So 2013, it was a complete mess. And I added this data into the thing and it just made no sense at all. Here's the pattern for when they arrive and here's the pattern for when they leave. So, well, there is something happening out here, but it's not the same as it was. And if you look at the distribution of these green dots and red dots and the blue dots, you'll find that they are considerably more mixed up than they used to be. And here's the bars for the southern birds, and here's the bars for the northern birds. They're now overlapping. And in fact, in this case, there was a southern bird later than all of the rest of them. 2020 was slightly different. We had satellite tracking, different place. We ended up with more northern birds in our sample than southern birds. That we tracked right through the staging period. And again, it's pretty hard to find that same pattern in the data. So here we go, southerns and northerns. But the interesting thing here is that the northern birds were later in leaving, as we'd expect, but overlapping completely in when they're departing Asia. So something has changed between 2008 and 9 and the current day. So if we put these together, we're going to layer these up. We have this beautiful pattern with a length of stay around about 30 to 50 days. And then we add in 2013 and you find not only are they further to the left, they're also further up the plot as well. Add in 2020 and it's mixed up there. So there's a couple of things going on. Birds are getting earlier and across the entire range, birds are staying longer in Asia. Now we know that this is going on from the monitoring of individuals. So this is an unusual situation where we can actually measure departure dates of the entire population. It's a small population, you can get exact counts, and the population is getting earlier by about half a day per year since at least about probably 2012, and this trend has been carrying on for the best part of a decade now. And in contrast to Marcel's talk yesterday about, or Ken's talk yesterday about turnstones, we can show in this population, adult birds, individuals, are doing the same thing. So each of these orange lines is the slope for an individual bird that has been recited over many years, an adult actively migrating. And this green line is the overall trend, or the green or the blue dotted line of these individually marked adults. And that slope is indistinguishable from this slope. So not only is the population getting earlier, we can show in this species and these individuals, it's actually adults changing their migration time that is at least part of what's driving this, rather than new birds migrating earlier. So if we sort of summarize these together, we've had a shift in when the later migrants in particular are leaving on migration. They're all mixing up, the later ones and so the northern birds and the middle birds are now mixing in with the southern birds and when they're leaving New Zealand. And they're all leaving, they're all staying for longer in Asia. So this is just box plots of the length of stay of these things, and these two are definitely staying about 5 or 6 days longer on average than they were in 2008. So an obvious candidate for what's driving these changes is climate change, of course, and indeed this is the first one that we went looking at to try to see, does this correlate with changes in the climate in Alaska? Should birds be leaving New Zealand earlier in order to arrive in Alaska earlier? But of course, it's not the only one. And we've seen lots of information coming out through the conference about these changes in food supply in Asia. So in Yalujiang, where we think at least probably 2/3 of New Zealand Godwits go, there's been this precipitous drop in the bivalve population there. And we're aware of reclamation or land claim all around the Yellow Sea. So the other alternative is that it isn't climate change, but it's habitat degradation that is causing these changes. So there are two options here. What is happening? One is that the birds are actually trying to respond to climate change, but they're failing to achieve that goal because of conditions in Asia. So if you sort of plan this one out, they would depart New Zealand earlier, they would stay longer in Asia because they aren't fueling as well, and therefore they're not achieving an earlier departure for Asia. So that is one possibility. There's another possibility that intrigues us a lot, which is that actually it's not climate change, it's that the birds are anticipating poor fueling conditions and are leaving earlier, and the later birds that have a shorter time period, or the later birds that in fact would suffer the most food depletion, are the ones that benefit the most from becoming earlier. So in that case, they are leaving earlier in order to have a longer stopover in Asia, and therefore they're leaving at the same time for Alaska. So maybe they've won. Maybe that is indeed the end goal for them. Either way, I think it's clear that the staging period in Asia has changed from what it used to be, and they are spending longer there. So some conclusions out of this: we wouldn't know what we were talking about if we didn't know where these birds were going to. And this is partly because of this latitudinal variation in climate in Alaska, which is a driver of the individual differences in timing. I think we hit it sweet. We hit the sweet spot at the beginning. I think we started at a time when conditions were good and there was what we would think of sort of the evolutionary equilibrium situation for them. But that system doesn't exist anymore. It's now been disrupted and their stopover has changed. And I think it's fueling conditions in the stopover in Asia. You know, it's a smoking gun that conditions there may be what's driving these changes. Intriguingly, or interestingly, this implies that birds have the ability to respond to past conditions and to do this year after year. So there must be some feedback mechanism within birds that allow this. And yeah, just a little caution that we see changes in timing. It doesn't have to be climate change necessarily. It could be other factors in their migration system. And that is where I'll end. Thank you very much.